And now the full pipeline in practice. So we start with pre-training. And what is pre-training? Next, token prediction blindly over our entire corpus from Common Crawl, from the internet, from wherever we have. Then we do SFT. This is the same loss, but now with structured data, data that we have curated, data where we have the context, instruction, and output triplets. Now, and the first is where we kind of learn the knowledge. The second is where we learn how to format it. The third is where we do DPO, where we learn preferences. And finally, we do something like GRPO, where it learns to reason. And if you were to, let's say, track accuracy across these stages for, let's say, benchmark accuracy over, let's say, tool calling, it's an example that we will see later. We will see that the base model does about 10%. It cannot answer most of the questions. After SFT, it does about 65%. After DPO, about 75%. And after GRPO, we get the final model, which gets us about 85%. So from 10 to 85 is very impressive. And practically, training with TRL. So TRL is essentially a Hugging Face library that we will use. And what this library does is it gives us SFT, DPO, GRPO, any of these in less than equal to 50 lines of code. Yeah. So coding ML is really, really easy. And two notebooks we will use in this lecture. We will use the tool calling SFT DPO comparison, where we compare SFT with DPO on tool calling. And the task is teach tool calling to this Qwen 2.5 1.5 billion parameter model, where we use these two methods, SFT and DPO, parallel from base model. So we have a base model and then we fine tune it using SFT and DPO and see what happens. And then second, we look at this other notebook, SFT GRPO comparison, where we teach math reasoning to this Qwen 2.0 0.5 billion model. And again here, we kind of do that what we looked at, and we see how GRPO is better than SFT with these custom reward functions, because we don't need an LLM to judge if the answer was right or wrong. We do those two clever things about checking if there is a think tag and checking if the final answer is correct. And the key insight, each method needs just about 50 lines of code if we use a library such as TRL. In SFT, we, data format, it learns that how to read the system prompt, how to read the user prompt, how to behave like an assistant. And key settings are, you would use a learning rate which is pretty high, such as, 2e 10 to the power minus 5. So 2 into 10 to the power minus 5. And you would do 2 to 3 epochs. You would also do something called as LoRa with a rank of 16 to 64. So I'll talk about LoRa later, or maybe just point you in the rabbit hole section. LoRa is low rank approximation. So we kind of create these low rank approximations and add it to the layers, and don't train all the parameters, just those LoRa parameters. In DPO, the data is, so the data is basically the winners and the losers, and the settings are here. We use a learning rate such as 5 into 10 to the power minus 6. And we only have, let's say, 10 to 20,000 pairs, or 2 to 10,000 pairs, right? Here we have 5 to 20,000 pairs. And finally, in GRPO, we have, the custom reward functions, where we have, the correct response, the wrong response, and we also have, the other things that we discussed. So the data is prompts only, because all we need are prompts, and for those prompts we get the rewards. We also need a reward function, and then from those rewards we calculate our value function by just taking average over all of it. And then we clip it if it becomes too high or too low, because we don't want the model to change too much. And we then do that clever trick of that pi 1 upon pi naught, because our model has drifted, and that is all that we do in this GRPO. And We will see this in the notebook, but if we look at this notebook, which is the base versus SFT versus DPO for tool calling, we see that the base model does about 31%, SFT does about 81%, and DPO does about 68%. And no tool call accuracy is better for DPO, and overall, the SFT and DPO do equally well. And so here we kind of show that in text, and this is going to be more clearer when we look at the notebook in a bit. Finally, live comparison, what each model actually outputs. So if we look at now the qualitative outputs of these models trained, if we kind of ask it, calculate my BMI, where the weight is 70 kilos and the height is 1.75 meters, the base model would start to do things like this. It would say, to calculate your body mass index, we need to divide your weight in kilograms by the square of your height in meters, and then it'll kind of do something, and it'll then divide, and therefore it'll get this final answer. Therefore your BMI is approximately 22.86. But SFT, it'll learn to calculate this tool, because we have this tool called calculate BMI. The base model did not know that we have this tool calculate BMI. A tool is essentially a function, so function calling, right? So because it did not have access to this, it does not call that function. But now we have this function and it calls that function, and so does DPO. And that is what is so cool about doing this alignment, about taking these powerful models trained by these frontier labs and then adapting it for our purpose with just 50 lines of code. The hard part, of course, is always data, right? So a little bit about LoRa. So like we said, we don't change the entire matrix. Instead, we kind of create this small, column into row, and then we kind of say that we only train these parameters, and these are much lower number of parameters to train as compared to our original model. And in summary, we do pre-training where we learn the knowledge. We then do supervised fine-tuning where we learn the format, right? Instead of continuing the question, which your pre-training will do, this will actually learn to answer. And finally, your RL gives judgment without changing the model too much. And together they transform this next word calculator into this helpful assistance that LLMs can be. And the final message is, this is really simple. We will next look at all this in code and then finally do a simple assignment where this knowledge will become ours forever.